Hi guys, Ms. Pasenka here. Today we are doing lesson 1.4, which is measuring angles. If you guys are at home, go ahead and feel free to pause this whenever you want. If you are just looking at the video to review, good for you. So today we are going to be able to classify angles by their measure, understand the different ways to name angles, and use and apply the angle addition postulate. So here are a couple examples of angles. If you guys have ever seen an orange or a clementine, they have those little sections which definitely have angles. A baseball diamond has angles. Pizza, if you cut it in triangles, there are definitely angles. Triangle has the word angle in it. And then this ladder makes an angle with the ground and with the building. So an angle is a figure formed by two rays with the same endpoint. So on your notes there, you're going to want to write that down. Pause it if you need to. I'm just going to run through this quick. How to name an angle? You can use a vertex. You can use a point on each ray and the vertex, so that's 3 points. And then you can also use a number. So for example, if we have this, okay, and we have the letters B, our vertex is A. Okay, I need to hold on a second. T. Okay, and we have a number 3 here. The different ways to name it is you could have angle A, which is its vertex. You could have angle BAT, or you could have angle TAB, which is, the point on each ray and the vertex. And then you can also have a number, which would be angle 3. So for pretty much every angle, there are 4 ways to name it, depending on, how you put your letters in order. For the second option here, for the second option, a point on each ray and the number, you have 2 different types there that you could do. You could do it in one direction, name it, or do it in the other direction and name it. So when you name angles using 3 points, the vertex must go in the middle. That is one of the most important things here. If you don't put the vertex in the middle, you are going to get that question wrong. The interior of an angle is the region containing all of the points between the 2 sides of the angle. So if I were to draw an angle here, okay, and here's my angle. Now the interior, I'm going to make that yellow, is everything inside of here. Okay? The exterior of an angle is the region containing all of the points outside of the angle. So the exterior is the outside. So if you need to draw a picture like that, use some colors, go ahead and do that. And pause it if you need to. Name the following shaded angles in 3 different ways. So I'm just going to name all of the ways possible. You guys can pause it here and try it. So for the first one, we have angle XYZ. We could also have angle ZYX. We could also have angle Y. There is no number here, so we can't use a number to name it. For number 2, you could have any of these answers. You could have angle ABC. You could have angle CBA. You could have angle 1, or you could have angle B. For the next one, it's only this shaded region here. So we're not going to use the other side of that angle there, the L, the point L. So for this one, we could have angle JKM. We could have angle MKJ. We could also have angle K or angle 2. That K does not look like a K. Let me try that again. Okay, so those are all of your options for numbers 1, 2, and 3. Again, if you need to pause it to write your notes down, go ahead and do that. Don't just skip on to the next slide because I'm going fast. Pause it. You have that option to do so. All right, so understanding how to read a protractor. We have a couple of different angles here, okay? When we are dealing with angles, we need to put the degree symbol. So like if you've ever baked, you might see something like, okay, put your oven to 350 degrees. We need to put that little angle sign. Whoops, I didn't want to do that. You need to put that little angle sign on our measurements, okay? So, first off, we are looking for number 4, the angle of MLN. Okay, now how we do that is basically, this is a 0 here, not there. Sorry, give me a second, guys. The number 0 is here, basically at this, you know, the straight edge right there on that line. So if we're going from 0 all the way to 60, we're looking at that outside number. That means that the measure of angle MLN is 60 degrees. Okay. For number 5, we have the measure of ML and O. Okay, we're starting at 0 on the left, and then we are moving all the way to the right to 90 degrees. If you guys have any questions, make sure to ask. Okay, the next one, the measure of angle Q, L, and P. Okay, so this one, because we're going from the right-hand side and moving to the left instead of left to right, we are going to start at 0 here, and then we're going to move this way to the inside number. So the inside number for QLP is 50, so that means QLP is 50 degrees. Next, we have measure of angle NLQ. So we have NL and, whoop, that got a little rogue there, sorry. We have NL and Q. Okay, so because now you have to think about this in different ways. Obviously, this cannot be 60 degrees, okay? Because MLN, which was this one, was 60 degrees. So NLQ is bigger, okay? So if we're starting, right, from 0, we need to get that inside, hold on a second here, the inside, the interior angle measure. So do you think, judging by these two numbers here, would it be 60 or 120? It's going to be 120 degrees. Then we have the angle measure of NLP. NL and P. Okay, so now this is a little tricky. Okay, one, you have to decide here, are you going to use the bottom number or the top number? Okay, now if you use the top number, you're going from 60 to 130. If you're using the bottom number, you know, you're going from 120 to 50. Either way, it's kind of like the postulate that we used for line segments. You know, you're just trying to find the difference in the numbers, and it has to be positive because angles are positive, the measures are positive. So if we go 60 minus 130, that's going to be a negative 70, which means it's positive 70, and 120 minus 50 is also 70. So that means that the angle measure of NLP is 70 degrees. I'm just doing simple math here. I'm just adding or subtracting. Okay? Then the last one, measure of OL, whoops, I didn't want that. OL and P. So this is going to be kind of similar to the last one that we did. We're going, again, you need to decide which numbers you want to use, the top ones or the bottom ones. If you're using the top, either way, you're going to have to get a positive answer. So you could either do, 90 minus 130 and get your answer and make it positive, or you could do 90 minus 50 and get your answer. Either way, the answer would be 40 degrees for that angle measure. Okay, so an acute angle is an angle that is more than 0 degrees but less than 90. A right angle is exactly 90 degrees, and it has to have this little guy in the corner in order to classify it as a right angle. If it does not, you cannot assume it is a right angle. An obtuse angle is more than 90 but less than 180, and a straight angle is exactly 180 degrees because that line is perfectly straight. Okay, I think when I learned it in high school, you can remember it by acute angle is a little angle, a teeny tiny angle, and an obtuse angle is a fat angle, like kind of like obese, obtuse. State whether the angle below appears to be acute, right, obtuse, or straight, then estimate its measure. So you guys go ahead and pause it right here and give those three a try. So number 10, because it is kind of wider, it's an obtuse angle, and I'm going to guess that it's about 135 degrees because I know that a straight angle is about here and a right angle is about here. So it's kind of in the middle there. Number 11 is, although it doesn't have, that little mark here, I am going to assume it appears to be a right angle, and a right angle is, 90 degrees. And then number 12, this one is a small angle. It's got a, a smaller mouth or a smaller width right here. So it's an acute angle, and so a 90-degree angle is probably like this. So I would say maybe it's 45 degrees because this guy is in the middle. Okay, pause it here and draw a figure that fits each description. An obtuse angle is a fat angle. So you have angle, sorry, those dots aren't perfect, but you have angle RST. Number 14 is an acute angle, and again, your angles don't have to match mine, they just have to fit the description. So you have angle GHJ. So here's your G, here's your H, here's your J. Whatever letter is in the middle, that has to be your vertex. And then number 15 is a straight angle. You have your vertex still has to be in the middle. Okay. Now congruent angles are when angles are congruent if they have the same angles with the same measurements. that you need to add onto your notes. Make sure that you have that. Pause it if you need some extra time to get it written down, or if I'm going too fast. Okay, the angle addition postulate is if point B is in the interior of AOC, which it is, it's in the interior, it's inside those two lines of the angles, then MOAB, the measure of MOAB, this guy, plus the measure of angle BOC equals the whole entire measure of AOC. Okay, that M, the M means measure in both. Okay, that little lowercase m means measure. So, using the angle addition postulate, I know that if they give me my two interior angles, angle measures, I can add those two together to get my big angle. And I can also use subtraction to get my smaller angles within the big angle. Okay, so number 16 is the measure of angle ABC. So I am looking for the big one here, okay? So that means I just need to add up the two angle measures that are inside. So I do 38 plus 32, which would be the measure of angle ABC is 70 degrees. For number 17, okay, so I am trying to find the measure of angle DEF, which, okay, we can look at that, right? And we can say, all right, I got 109 and I got 71. If you add those two together, what do you get? You get 180 degrees. So the measure of angle DEF is 180 degrees. And again, make sure that you have that degree symbol there. Number 18, so it is asking us, again, to find the big angle measure, M, N, and R. So if it's asking us to find the whole thing, we need to add the two together. So 41 plus 92. 41 plus 92 is 133 degrees. Going on. So here's where we get some more algebra like we did on Thursday and Friday. Okay. Now it is asking us to find this angle. Let me change that. Hold on. It's asking us to find this angle measure, right? So measure means it has to be a number. And it's also asking us to find this angle measure. So they give us x's, but they also give us the measure of the whole entire angle right here. So what we can do is use algebra to help us find that answer. So we know that 4x minus 20 plus 3x plus 14 equals the whole angle of ROT, so which is 155. So I need to then combine like terms and solve for x. So 4x plus 3x is 7x. Negative 20 and 14 is negative 6 equals 155. You would then add 6 to both sides, and you get 7x equals 161. In order to get x by itself, you need to divide. So you get x equals 23. So you can use that to help you find the measures of angle ROS and the measure of angle TOS. So I'm just going to plug that 23 in. So 4 times 23 minus 20. And I have, hold on a second, 3 times 23 plus 14. So 4 times 23 is 92, and 92 minus 20 is 70 degrees. 3 times 23 is 78, I believe. No. 79. Nope, 69. Sorry. My bad. It's definitely 69. 69, and 69 plus 14 is 83 degrees. Oh, and you know what? I made a mistake up here too. This should be 72. It's almost Friday, guys, and, well, actually, I'm making this when it's almost Friday, so my brain is a little bit of mush. Okay, and then to check, you know, you can add your 72 plus 83 and make sure that it equals 155. It does, so we are good with those two angle measures there. Now here is where I would like you to pause it and try these guys on your own. Obviously I'm going to go over them for you, but try and do them on your own for some extra practice. So for number 20, we are trying to find the measure of WVU. And it tells us that WVB is 71 and BVU is 63. So it gives me WVB and it gives me BVU. So now I can just add those two together. So 71 plus 63 would be 134 degrees. Is the angle measure of WVU. For number 21, we are trying to find out, now this is different. It gives us the angle measure of JKA, which is this one here. It gives us the measure of JKL, which is this whole entire one here, okay? So we're trying to find this one here. Whoops, I don't want that color. We're trying to find this guy here, okay? So this is where we're going to have to do some subtraction. So I'm going to take my JKL measure, which is 178, and I'm going to subtract the little yellow piece, the 24. So I end up getting 154 degrees as my measure of angle JK, or sorry, that's wrong, AKL. Okay. Draw and label the following angle. You need an acute angle, so obviously it's got to be a little cute one. And you need an I, you need a J, and you need a K. And it could also be, you know, going this way with the points in a different spot. You just have to make sure that middle point, your vertex, is always the same. Name the angle in 2 different ways. So you guys can name it in 2 different ways. I'm going to list all 4 ways that you could name it. You could say angle MLK. You could have angle KLM. You could have angle 2, or you could have angle L. And that is the end of the notes for today. Again, once you're done, make sure to upload them onto Canvas. We will have a little lesson quiz or homework check or whatever you want to call it on Wednesday. So this is all we had to get through for today. If you need extra practice, let me know. I can send you guys some stuff, but look for our homework for Wednesday. And make sure to upload all of your notes and finish all of your missing assignments if you have any. See you guys later.